The moment has finally arrived. After more than a decade of construction, testing, and astronomical expectations, the Vera C. Rubin telescope has opened its eyes to the universe, and what it saw left scientists speechless. The first images released are more than beautiful, they're revolutionary. Each pixel in these frames carries information that could transform our understanding of the cosmos. In this video, you'll discover what the largest digital telescope in history captured during its debut, and why this is already being called a turning point for modern astronomy. But before we dive into the images that are making headlines, let's understand what makes the Vera Rubin telescope so special. Located high on Cerro Pachon in the Chilean Andes, the Vera Rubin Observatory was designed to do something no telescope has ever done: scan the entire sky, repeatedly, night after night for 10 consecutive years. It's the centerpiece of an ambitious project called the Legacy Survey of Space and Time, or simply LSST. Its 3.2 gigapixel camera is bigger than a compact car. Each image covers a massive area of the sky, equivalent to 40 full moons. Every 15 seconds, a new picture, and in just a few nights, the entire visible southern sky will be rescanned. This unique capability makes it the first truly cinematic telescope, able to capture the universe in motion like a time-lapse cosmic film. And now, with its first light, the first real astronomical test, Rubin has shown exactly what it's capable of. One of the first images released was of the galaxy NGC 1398, more than 65 million light-years from Earth. The image is so detailed it reveals previously unseen structures, faint spiral arms, star-forming regions in bluish hues, and an intensely active galactic core. What's even more impressive? This wasn't even a planned observation. It was just one of the telescope's automatic calibration shots. And even so, it surpassed in resolution and depth much of what we've seen before. Another image that drew attention was of the globular cluster Omega Centauri. This dense group of stars has been photographed by countless telescopes, including Hubble. But Rubin achieved something unique. It captured all at once hundreds of thousands of individual stars, each with different brightness, color, and motion. This unprecedented richness of data may help us better understand the origin of these clusters, and even reveal whether some of them are remnants of galaxies devoured by the Milky Way. And the surprises didn't stop there. In a random sweep of the sky near the constellation Pisces, Rubin detected brightness variations in dozens of variable stars and quasars in just one night of observation. This is already a glimpse of the staggering number of transient events the telescope will be able to track in real time. Astronomers compared the experience to turning on a floodlight in a room that had only ever been dimly lit, and inside that room, finally seeing everything hidden in the shadows. But perhaps the most promising aspect lies in what hasn't even been fully analyzed yet. Within the initial data, scientists have already identified potential supernova candidates, previously uncharted solar system objects, and even early signs of weak gravitational lensing, those tiny distortions in light from distant galaxies caused by the presence of dark matter. That means that even in its very first snapshots, Rubin is already touching on some of the greatest mysteries of cosmology. And it's no exaggeration. One of the telescope's main scientific goals is to create the most precise 3D map of the universe ever made, using the light from billions of galaxies to infer the presence of dark matter and dark energy, which together make up 95% of the universe, and about which we know almost nothing. In fact, the number of galaxies Rubin is expected to detect is mind-blowing. Up to 20 billion galaxies, many never seen before. And just in the first images, hundreds of new galaxies have already been cataloged. It's as if we've spent our entire lives looking at the universe through a keyhole, and now, suddenly, we've opened a panoramic window. And this window also looks into our cosmic backyard. In its early test nights, Rubin also captured near-Earth asteroids with unprecedented precision. Thanks to its wide field of view and high observation cadence, the telescope will be essential for monitoring potentially hazardous objects, capable of detecting about 90% of asteroids over 140 meters that cross Earth's orbit. But beyond numbers and graphics, there's something deeper in these first records. Watching Rubin in action is witnessing the birth of a new way of observing the sky, astronomy that no longer depends on finding needles in haystacks, but scans the entire haystack every night to see what changed. It's real-time science, dynamic exploration, collective discovery. And the most beautiful part? All of this data will be public. Universities, research centers, amateur astronomers, and the curious from around the world will have access to this gigantic archive of cosmic images. Teams are already training artificial intelligence to watch the sky alongside Rubin, hunting rare events and anomalies. And there's great hope that the next revolutionary discoveries in astronomy won't come just from renowned scientists, but maybe from an ordinary person, at home, looking closely at a frame no one else noticed. Rubin's first images gave us a glimpse of the future, and that future is bright, vast, detailed, and in motion. If this is only the beginning, just imagine what we'll see when it's operating at full capacity, scanning the entire sky every night for a decade. The universe is changing, and now we can finally see it happen, almost in real time. Like this video, share it with a fellow space enthusiast, and subscribe to the channel to follow the next chapters of this cosmic revolution. The Vera Rubin telescope has begun recording the story of the universe, and you're invited to watch from the very first frame.